Welcome to Time to AI. I'm Jason Turpin. This is the second video in a foundational series encompassing many aspects of large language models. In this video, I will talk about products based on large language models, such as ChatGPT and the Copilot Pro. We'll talk about their architecture and what it means to be an AI application. We'll also dive into the data structure of conversations and how these services likely handle accessing information on the internet. Let's do this. Leroy Jenkins. In the last video, we covered examples of large language models. Today, I'm going to cover commercial systems that are powered by large language models. The most obvious AI applications are the large chatbots, such as ChatGPT, Copilot Pro, Google's Gemini Advanced, and Anthropic's Claude. These are monthly subscription services, all right at or around $20 per month. They all have image generators attached. These are different LLMs, such as DALL-E 3, that requests are routed to as needed. All of these can access the internet to provide up-to-date information. They also provide API access for developers, but that's a topic for another video. They differentiate via add-on services. For example, OpenAI offers the MyGPT features, which allow users to build custom chatbots. They also offer varying levels of multimodal inputs, accepting images, text, video, and audio. So, how do they work? Here's a diagram that covers the basic flow of these systems, at least for the beginning of a conversation. This may look complicated, but we'll walk through it. It all starts with the user's prompt being submitted to the system. The system checks the request for inappropriate or otherwise offensive content or requests, and also determines the intent of the request. Is the user asking for an image, text, or maybe audio? The process will then flow down the necessary pathway based on the request. We're going to follow the text path. All these systems can perform internet searches and retrieve internet content. The exact details and implementation for this are proprietary, but we can ascertain what's going on. More on that shortly. At this point, the system has to ask itself, do I need to access the internet? How it does this is also proprietary. Next, a system message is attached to the request. This is the personality of the experience. Grok is supposed to provide rebellious answers, whatever that means. If I want that, I'll just create a persona along those lines. For the systems we've mentioned, this is going to be something along the lines of, you are an AI assistant who blah blah blah. I believe these are rather plain and straightforward. Finally, the original prompt, any internet-related content, and the system message are all passed together into the large language model as a unified request. I'm not 100% sure about this, but the response may go through another content filter similar to the first. I question post-processing, given the models can be jailbroken to produce outputs they shouldn't. Finally, again, the response is sent to the user. That's not so bad. There's the content and intent check, some pre-processing and manipulation, the LLM call, and the response. But that's just the first call. It wouldn't be a chatbot without conversational memory. Until a new chat is started, the entire content of the conversation is passed along with any user's new prompts. More about that in a second. Anyway, that's the chatbot. Now let's hit on the other topics. First, what does the conversational data look like? How complicated is managing conversational memory? Here's an initial prompt and response without any internet content. All this is JSON based. It's just a JSON string with system message, user prompt, and the assistant response. Other parameters such as temperature and top key are also passed as part of the call, but not as part of the prompt itself. And here's what it looks like after a second prompt. A conversation is started. You can see how the conversation works. New prompts and responses are just simply appended to the bottom of the message chain. This entire message chain is sent to the large language model for each prompt. There are limits on how long conversations can be. This is called the context limit. The models in these examples have large context windows, so unless you're pasting books into them, you probably aren't going to hit the limits, but it's something to consider and be aware of. Now let's consider the retrieval of internet data. Why is it needed? Large language models have cutoff dates, which represent the last date for which a model has information. So more recent news or world events will be unknown to the model after this date. So let's check this out. What's the cutoff date for the service you're using? You can just ask the model for this date. Let's try it out here. So I'm using ChatGPT 4.0, their new model that came out, I think, today, actually. And we're going to say, what is your data cutoff date? October 2023. So it's not going to have facts or knowledge past October 2023. Let's ask GPT-4 on Azure. And I know this is the older model. This is just GPT-4 Turbo. So what is your data cutoff date? April 2023 on the original model. If I switch back to ChatGPT and switch this to GPT-4, what is your data update? December 2023 this time. So you can see the differences there. The internet is also required for specific details that the model wouldn't have anyway. Things like stock prices. It doesn't know the stock price history for a given stock, but you can ask it questions along some lines there. So back to ChatGPT, let's just say, let me grab this. What's the current price of Google's stock? And if you watch, it goes out searching the web. There's what it's looking for. And it tells me that. Now I'm going to go ask that same question of Azure. The current price of Google's stock. I'm sorry, but it doesn't know that. It can't tell you. It's not sure of that. Let's try another little more specific example. What was Google's closing price on January 17th, 2024? So, to arbitrary date in the past. There we go, 138.37. Again, if I go back over to Azure, it will not know what I'm talking about. So as you can see, ChatGPT had to go out to the internet to fetch those results, and the Azure, the raw model itself, can't tell you those results because it does not know those things. So what are they doing here with regards to the internet? We know some things here. First, internet search is being performed. For ChatGPT and Copilot Pro, we know they're searching Bing for internet results. I could probably guess the search engine behind Google's Gemini without trying too hard. The actual search phrase appears to be displayed, at least for ChatGPT and Copilot Pro. It does not match the prompt value, nor should it. Or it doesn't match the prompt value every time, nor should it. It searches the internet only for what it thinks it needs. However, it figures that out. And from there, it retrieves at least one result from the internet, possibly from a cache of more common results. That result is probably cleaned up to remove ads or website structure code. I'm betting they chunk the result and perform a similarity search based on the internet search value or part of the user's prompt. The parts of the internet source that appear relevant are then included in the results. Entire web pages are probably not submitted to the LLM for quality and efficiency purposes. This has been an explanation of how the major commercial chatbots function, along with additional details around how chatbot conversations work, and how they include internet content for up-to-date results. I hope you found it interesting and instructive. Please like and subscribe, and until next time, have a good one.